Hey, how's it going, folks? My name is Hellbent, and welcome to AutoHotkey Game Maker tutorial number 4. In this one, I was going to start us looking at how to add in a simple AI or a simple NPC, but something's come up and I've decided to change the path, and we're going to be looking at something else instead. So this is what we were going to be looking at, is starting to add in a simple AI. So here I have an example of two simple NPCs that are fighting each other. They have some rules attached to them, and they will fight each other until they die, and then they'll respawn and start over again. Infinite amount of time. So they can die a million times, respawn, come again. Okay, so like I said, instead of doing this, which we will come back to later in a later tutorial, in this one we're going to be looking at simple bouncing. Now it's bouncing in the context of like an old game, like let's think Pong or things like that, where we're not actually applying a gravitational force. Well, I'll cover bouncing with gravity maybe shortly after this one, before I go into NPCs, or maybe I'll do the NPCs and then come back to bouncing with gravity and things like that. I don't know. You let me know. You let me know in the comments, what would you rather have? Would you rather go into the beginning steps of doing the NPCs, or would you rather see some more on the physics of like having an object that bounces with gravity applied to it? Which would be similar to the jumping tutorial, but you know, a few other things added to that. Okay, so like I said, this one is going to be on bouncing. Now, what we're going to do is maybe if I show you something, it'll make it easier for me to explain it. Okay, so here I have a script that this works in a completely different way. The way that this thing operates is completely different than what we're going to be doing, but certain things about it are the same. Okay, so here I have a game board, and I can add these little bots into it. So let me go ahead and add 5 bots. And they just zip around, and every time they encounter an edge or another object, they randomly choose a new direction, and they start moving in that direction until they counter one of the other bots or one of the walls again, and then they change directions again. Right? What would happen though is, because of the way it's set up, like these bots, I have them, I use these as a testing ground to program other things, like telling these bots how to use certain different kinds of logic to do different kinds of things. So this is their default. They just bounce around, but then I tell them to do something, and then they start doing that. If I was to right now make it so that way the only time they decide to change directions is if they hit the walls, basically, they would quickly, even though they spawn in at a random point, very quickly, because of the choices that they have, they would end up following a pattern, and that pattern would be basically 3 boxes with an X in it. So if I go into my code, so here, let me run that again, and let me try adding 100 bots, 200 bots. Okay, so right now it's their pattern, because of the way they're checking to see if they're colliding with another bot. Their pattern is all over the place. There is no predictability. There is no path that you could say that this particular bot's going to follow forever, right? Eventually it's going to hit a bot and change directions. But if I go into my code, and if I disable their ability to check to see if, so I'm going to make it so that now they don't care if they collide with each other. The only time they change direction now is if they hit the edge of the map. Let me make sure. Okay. So now if I take those bots, because they're only going to be changing directions when they hit an edge, they're going to start moving in the eventually, very quickly, they're going to start moving in the same pattern over and over and over again. There's only going to be certain points on the screen that they're ever going to occupy. So if I do random and 100, here, let me do 200. Okay, so right now it's a lot of noise because they spawned in at random points, but very quickly their choices are going to start to become less and less and less, and we're going to end up with basically what looks like 3 boxes with X's in them. And let me add a couple more bots to speed that process up, or so you can see. So right now they're not they don't care if they overlap each other. They don't care. So you can already start to see this X right here, this X right here, and another one, let me see, right going that way. So this one it's less, but right there and right there. So we have an X right here. We have the border of that box right, let me see, I need one moving down. So there's this line here that they're following, but there should be another line somewhere over here that they also follow. There we go. This one, this green bot. So we can see that this is a box right here with an X through it. This is a box with an X through it, and this is a box with an X through it. Alright, so that's, if we were to, unless we do something with our bouncing, so if we create a program right now that we have something that's bouncing, no matter where we start it, if we just reverse its direction, like if we just give it a basically, so let's say it's moving in the X direction, -1, and it's moving in the Y direction, +1, it's going to eventually hit here, and then if we reversed, if it's hitting along the y-axis, we just reverse the y direction. So if it was positive, now it's going to be negative, so it'll start bouncing going this way. If it hits along the x corner, we'll just reverse its x. So if it was going negative, now it's going to go positive, right? Eventually, we're going to have the same spots getting hit over and over and over and over again. What if that's not a very good system? What if we want to have it so that way it could hit at any point along the x and y axis, right? So if it's their infinite amount of positions, or if it's 100 pixels tall, it could hit at 100 points rather than just 3 points for any one of the sides, right? Because if we just have it so that way it's just reversing direction, it's only going to have like a couple of points along each side of the game that it's going to hit. So we want it so that way it hits any particular x value or y value. So I'll leave that. I'll come back. I'll fix that later. So that's what we're going to look at this time. We're going to look at how we can create that bouncing object for like a Pong game or any other kind of game that you want to create, where you have this bouncing thing that doesn't just repeat the same path over and over and over again. Alright, most of the stuff we're going to be covering in the beginning of this is stuff that I covered in the first 3 tutorials, so I'm not going to really say much about it while I'm typing it out. You should be up to speed on how to create your objects, how to create the simple background for your GUI, how to create the game loop, how to update the game objects, etc., etc. It's in some of the logic that's in our game loop that we're going to adjust. So I'm just going to go ahead and set up my script. Single instance force. I'm going to immediately add in my return and add in GUI close. I'm also going to make it so that way, rather than adding an emergency exit hotkey, I'm just going to say that if the window's active and if I press escape, go ahead and exit. So if I do GUI escape. So if I either hit the X button or the GUI or press escape, then it's going to exit app. I'm going to create my timer. I'm going to call it game cycle. And I'm going to set it to 10 milliseconds. And then down here I'm going to add that in. And when we do our first test, I'll make sure that the game cycle is working. I'll just put a tooltip in here that says here. So if we get a tooltip that says here, we know that the game cycle is working. Okay, the next thing I'm going to do is, so what we're going to do in this one is we're going to create some of the elements of a Pong game. You know what? I am going to... we're going to create basically a game. We're going to create a paddle object, and we're going to create a ball object. We're not going to be creating Pong. We're just going to make it look sort of like Pong, so it makes things make a little bit more sense. There's a little bit of context to what we're going to be doing. So for our paddle object, we're going to make it so that way we can move it, but the ball and the paddle are never going to interact. We're not going to check for interactions between these two objects. All we're going to do is we're going to check to see if the ball hits the borders. So if it hits up there, if it hits over here, or hits over here. We're just going to be worrying about this ball and how it bounces. Later on, maybe in another tutorial, we'll talk about how you can have it so that way if it hits the ball, so the stuff that we're going to be doing, it would kind of go right into how you would program this paddle. So for example, if my ball hit between there and there, a specific action would happen. If it hit between here and here, a specific action would happen. If it hit between here and here, it would have an action, and here, or if it hit anywhere that's open space. Right? And likewise for an enemy paddle. So if it hits here, maybe it makes the ball move back in the same direction. So if it was coming down, maybe it sends it back up, but at a sharp angle. Maybe this one just reverses the angle, but decreases its trajectory. Maybe here it does the same, and then maybe here it does a sharp angle. Right? So we're not going to be worrying about how it interacts with that, but this stuff here, how it moves, the velocity. So let's call it angles. So we'll call that angle. We'll call that angle. We'll call that angle, and etc. Right? So we'll look at kind of this stuff here for the ball. So that way, if the ball is moving from this side to the other side, as it bounces around, eventually it'll hit every point on this side, and the top and the bottom. Okay, so that's what we're going to be doing. So to do that, we're going to need two objects, one for the ball and one for the paddle. So we'll create the paddle first. Paddle : equals. Our paddle is going to have a X position that I'm going to set to start at 10 pixels from the edge. The reason why I'm going to have it 10 pixels, I don't need quotes. The reason why I'm going to do 10 pixels from the edge is because later on I'm going to make it so that way it shows with a mark where our ball hits. So we can actually, when we're done with this, we'll actually have a way of actually seeing if our ball is hitting every single point, or if it's possibly hitting every point along the border of our game, or if it's following every single possible path that it could. So anyways, it's going to have an X of 10. It's going to have a Y of, I'm going to make the board 590 pixels. I'm going to make the board 600 pixels wide. So I want to have a margin of 10, and the piece is going to be, the paddle is going to be 10 pixels. Oh wait, this is the paddle. I'm thinking it's the ball. We'll put the, now, okay, let me show something. We can infer that if our ball hits at every point, or every conceivable point along the y-axis on both sides, we can also infer that it's also doing the same along the x-axis. So rather than showing both the y-axis and the x-axis, we're just going to show the y-axis. So we'll show where the ball hits along the y-axis on either side, and we can infer that if it's in fact hitting every single possible point, that it would also be hitting every possible point along the x-axis. So we're not going to show the x-axis, so we don't need a margin for our y-axis, so we can set our paddle, to begin with, we'll set it at 0. We're also going to need a width and a height, so the width I'll set to 10 pixels for our paddle, and I'll give it a height of 100 pixels. I'll also give it a speed. Now we only need one speed because it's only going to be moving up or down, because it's a paddle that sits on one side of the screen, moves up and down, so I'll just call the variable here, speed, or it could be velocity, y velocity, blah blah blah. But speed, and I'm going to set its speed to 2. Then we need a ball object. Later on we'll go into creating classes and things like that. For now, let's keep things as simple as possible with just this kind of coding. The ball object is going to need a X. We'll start it at the opposite side of the screen. Now, like I said, I'm going to make my board 600 pixels wide. I'm going to have the ball. We're not going to be, like I said, we're not coding a game. So what I'm going to do is, as soon as we run it, the ball is going to automatically start moving. And I'm going to have it start moving. I'm going to put it up here to begin with, and I'm going to set its direction to be moving to the left and down. Or in other words, it's going to be basically moving in this direction at some angle. So the X position, I want to have a margin so that way we can place some marks afterwards. So I'm going to give it, so since our board is 600, I'm going to make the ball 10. So the X position, which is this corner, the left corner of the ball, I'm going to set that to be 580. So it's 580 plus the ball's width is 10 plus the margin is another 10. That gives us 600. So the ball's X is going to be 580. The Y is going to be 0. The width, 10 pixels. The height, 10 pixels. For the speed, we're going to be adjusting each individually. So it's not going to have a common Y speed and an X speed. It's going to have a certain speed that it moves along the X-axis. That we're not going to be adjusting the X-axis speed throughout this tutorial, but you'll see what we do with the Y-axis, and you just do the same thing with the X-axis if you want to adjust the X-axis speed as well. But for this one, we're only going to worry about the Y-axis, and you end up getting the same result anyways. So we're going to have a speed that it moves along the X-axis. To begin with, we're going to be moving from the right-hand side of the screen to the left-hand side of the screen. So the velocity is going to be moving in, or the direction it's going to be subtracting from or adding to our position is going to be a negative number because we're moving in this direction. So we're going to create a variable called, or a key called X speed. And its value is -3. Next, we're going to create one for the Y speed. So this is how fast it moves up or down. Y speed. And we'll also set it to 3. But since we're moving in the downwards direction, the numbers down here are bigger than the numbers up here. So we are moving in a positive direction. So it'll just be 3. Or +3. But since it knows that 3 is the same as typing +3, it's just 3. Okay, so there we have our ball object. Now let's go ahead and create our GUI. So we'll do GUI 1. We'll call the GUI 1. We'll set it to always on top. I'm going to set its color to black, so that way things stand out a little bit more. I'm just going to go ahead and show it right away. I'm going to give it, like I said, a width of 600, and for height, I'll go 300. But you can pick any dimensions you want. Just make sure you follow the steps that we're going through and change your values as you need to. We'll call it the game. And then, bam, Bob's your uncle. Okay, so we have our GUI. Now we just need to add our pieces to it. So let's go ahead. I'm going to use progress bars so that way we can add some color to it. In future tutorials, we'll go into adding images and everything like that. But these things they're not needed right now. Simple geometric shapes are fine for now. So we'll do GUI 1, add progress. We're going to use our objects. So X is paddle dot X, Y is paddle dot Y, width is paddle dot width, height is paddle dot height, and now we will add a variable. I'm going to call this control paddle. I'm going to make its main color aqua. Nah, teal. I'm going to make it teal. And I'm going to make its background, or the border, the trim around it, white. And that's it for that. Now I'll set the progress to 100 so that way it uses our colors properly. So that's our paddle. I'm just going to duplicate this line. Because of the editor that I have, I can do this. If you're using Notepad or whatever, or maybe some other things, you might not be able to do this. But I'm just going to copy and paste this line basically. I'm going to select anywhere in it, and then I'm going to press Control D to duplicate it. And then I'm just going to go through and change it so that way we're working with the ball object now. So I'm going to take the ball object, and this is now ball X, ball Y, ball width, ball height, and I'm going to call it ball. And I'll change the color to yellow with a background of blue. Make it look as ugly as possible. Okay, so we have that. Like I said, although we're not going to be using the paddle, we will add in, just for the hell of it, we'll add in the functionality of how to actually move the paddle. So that's the first thing we're going to do. We'll run this first, check out what it looks like, see if we have any errors so far. So here we go. We have our paddle that's sitting up here, and we have our ball that's sitting over here. You know what? Is that bright enough? Maybe I'll change the color of that to lime. I don't know. Maybe that's a little bit brighter for you. I'll change the border to white. Okay, so anyways, there's our ball, there's our paddle. As soon as we start the game, the ball is going to start moving in this direction, and our paddle will control with our thing. But like I said, we're not going to actually test to see if our ball hits our paddle. Instead, we're just going to be testing if it hits that side, or the top, or this side, or that side. So let's go ahead and make it so that way we can move our paddle. If we press the up arrow, and if our paddle dot X is greater than 0. So if our paddle's X is greater than 0 and we're pressing up, go ahead and take our paddle's X position and add to it, minus equals, in our case we're going to be moving up, so we're going to be minusing, so we'll minus equals the paddle speed. Okay, else if get key state is down, or if we're pressing the down arrow, and if our paddle dot X is less than the height of our game board minus the height of our paddle. So our game board is 300 pixels minus paddle dot H. What by now you should start moving into having your game as part of an object. so you can create, so that way, or at least having variables for it. An object's the easier way. So so that way in this part here, so let's say if I used, let's say for its height. Oops, okay, hold on. We're not moving along the x-axis. If we're moving, we're only going to be moving along the y-axis for our paddle. So it's if our paddle.y is greater than 0, and if take our paddle.y and subtract our paddle speed. Else if we're pressing down and paddle.y is less than 300 minus the paddle.height. Okay, so this 300 here, let's assume that we put this into an object. It would be, you know, something like game board.w, right? And then instead of having this checking to see if we're less than 300, we would be checking if we're less than gameboard it would be height, sorry. Gameboard.height minus paddle.height. But we're not doing that. I'm doing it hard-coded because we're not going to be changing that. Okay, so if we're pressing down and we're not at the bottom of the screen yet, go ahead and take our paddle.y and plus equals, because we're moving down, we're adding to our y position, our paddle.speed. Okay. We'll go down a couple lines, and right before our return, we'll actually do the draw of we'll do the move for our paddle, or the drawing of it. GUI control. Window 1, we're going to be moving. What are we going to be moving? We're going to be moving the paddle. And where are we going to be moving it? Since we only need to move along, we're only going to be moving along the y-axis, we only need to represent that. So we'll do y paddle.y. Okay, now because our ball is sometimes going to go over top of our paddle, because we're not actually testing to see if it's impacting it, sometimes it's going to add some smudges as these two progress bars overlap each other, because we're not working on two different layers. So what we'll do is we'll create another variable, and we'll put it at the beginning of our game cycle. So up at the top, we'll create another variable that we're going to call frame counter. We'll set its value to 0, and then as soon as we come in here, we'll say if plus plus, so add 1 to value of frame counter, and then check to see if it matches a condition. If frame counter equals 100. So if it's been 100 frames since frame counter, so frame counter starts at 0, we run through, now it equals 1. It doesn't equal 100 yet, but eventually it'll equal 100. Once it equals 100, redraw, or basically refresh our paddle and ball object, so that way if they have any distortions in the image, it'll fix them. So we'll say GUI control, window 1, the subcommand is redraw. And what are we redrawing? We're redrawing the paddle. And then I'm going to duplicate this line by selecting anywhere in it and pressing Control D, and then we're going to redraw the ball. And then what we're going to do is we're going to set frame counter back to 0. So every 100 frames, it'll redraw our paddle and ball. Okay, so let's go ahead and have a look at what we have so far. So our ball doesn't move, but our paddle should. So if I press down on the paddle, it should keep moving until we hit the bottom of the screen. And if I'm moving up, it should hit the top. Now you'll notice I didn't add any extra conditions in here to see if my paddle has moved up out of the screen. So if my paddle is getting into negative numbers, like if I was moving at, let's say, 13 pixels per frame, eventually I'll get to the point where it can go below or above. So I might want to do some compensation, but because I'm using a very specific number, which is 2, which is divisible by the height and the game board, I never actually have to do that test, because it's always like its position, let's say its Y position will be 0, the next position would be 2, the next position would be 4. Eventually it would get to the bottom of the screen, and that position would line up with the bottom of my screen. So I don't need to compensate to see if the paddle is ever going to go up above or down below. But if you're using a different speed, such as 3, if I set the paddle speed to 3, for example, if I go to the very bottom of the screen, I would end up going below the screen, right? So I would have to compensate and reset its value to be at the bottom of the screen. We covered this in the previous tutorials, but I'm just clearing up that I don't have to do that now, because I'm using a value for the speed that works out with the height and the size of my game board, so it's always going to sit inside of my game board without me ever having to check. Okay, so we have our paddle. Now let's go ahead and do something with our ball. And the first thing we're going to do with our ball is we're just going to check to see if our ball is still inside the inner dimensions of our screen. So as long as it's not out here, what we're going to do is we're just going to say keep moving in whatever direction you're currently going. Whatever direction that might currently be. So it's not going to change any directions, it's just going to take its current value and add its current speed to that. So we'll say if ball dot x is greater than 10 and ball dot the reason I'm using the 10 is because we have that margin that we want to use for something else later. So that's why I'm not letting it get right to the left-hand side of the screen. Likewise with the right side. The top and bottom I don't care, but the left and right I want to leave a margin of 10 pixels. Okay, so if ball x is greater than 10 and ball x is less than the width of the game board, 600, minus the paddle, the ball's width, minus the 10 pixels that I want to save. To make this a little bit easier, I'll just change this to 590 minus the ball's width. I could also further just say 580. Right? I can get rid of this and say 580, but it's better if you see these kind of examples a few times before you start worrying about hard coding values in there. Okay, so we have its x, so we know that it hasn't passed, we know that it's still on this side, we know that it's over here somewhere from this side, and we know that it's over here from this side, so it's somewhere in here along the x-axis. Now we're going to check to see if it's in the y-axis somewhere in here between the top. So it's in there. So we'll say and ball dot y is greater than 0 and ball dot y is less than the height of our map, 300, minus the ball's height. So as long as this just checks to see if we're still in the middle of the game board. If we are, what we're going to do is we're going to take our ball's x and y position and add to it its current speed, or its current set speed. Ball.x plus equals. Now we can use plus equals here, because even if sometimes our numbers are going to be negative or positive, but either way, regardless of whether they're negative or positive, using plus equals is going to work out the exact same. So let's say that right now the x speed is -3. Let's say our x is at 100. If we add -3 to it, it means ball X is now 97. So it's the same as if we minused 3 off of it. I'm sure I don't need to say that, but just in case. So we're going to take ball X and we're going to add to it we're going to say ball X equals ball X plus ball X speed. Or ball X plus equals ball X speed. In this case, if it was 100, now it's 97. We're going to do the same thing with the Y. The ball's Y position plus equals the ball dot Y speed. And that's it. Down at the bottom, down here is where we'll update our ball. GUI1, move what? Move the ball. Move it where? Move it to the X and Y. Okay, so right now it is going to go until it hits the first wall. As soon as it hits a wall, it's going to stop. So we don't have anything in here yet to set it to bounce. Okay, apparently it's not going to do anything because one of our values is in that. Maybe I do need the extra condition. Here, you know what I'm going to do? To make it work right away, I'm going to change the ball's Y position, X position and Y position to be 10 pixels over. So I'm going to go 570 to start with the X and 20 to start with the Y. And now because it's Y and X are moving in the right directions, we should immediately see a change. There we go. Okay, so it hit as soon as it hits the bottom, this is no longer true, so it stops. Okay, next thing we're going to do is if the ball hits the top or the bottom, so if the ball is moving along and if it hits the top or the bottom coming from either direction, all we're going to do is we could do the same thing we're going to do with the Y-axis later, but we're not going to. We're going to keep this a little bit simpler so we can get through the code, and then you can just take what you learned from the Y-axis later and incorporate that into the top and bottom bouncing if you want. But all we're going to do is if the ball hits the top or the bottom of the screen, all we're going to do is change its direction along the Y-axis. So if right here, let's say if Y is going 3 pixels per frame, when it hits the bottom, it's going to change that to -3. So now it's moving upwards. So it's moving down, 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 hits the bottom, and then changes it to the opposite, and now it's moving up. All right, so we'll check if ball dot Y we'll check the top first. If it's less than or equal to, do I want less than or equal to? No, you know what? We'll just say if it's less than. No, it has to be less than or equal to, because we're only checking because otherwise it's going to cause problems with that. So we'll say if the ball's Y is less than or equal to 0, or if the ball dot Y is greater than or equal to the bottom of our screen minus its height. So the bottom of our screen is 300 minus the ball's height, which is 590. So if our ball's y is 590 or greater, this is going to be true. What we're going to do in here, if that's true, so if it hits the top of the screen or the bottom of the screen, what we're going to do is we are going to first, we're going to do a ternary statement where we're going to check to see if ball.y if the ball.y is okay. The reason why I'm doing what I'm about to do now is because we want to, I'm going to compensate, just like how we didn't have to do any compensation with the paddle because the numbers added up perfectly. So that way, if I move down, it's never going to get below the bottom. So I don't need to check to see if I've gone below the bottom. And I never need to check if I need to go above the top. With our ball, because its speed is such that it can actually get below the bottom of the screen and it can get above the top of the screen, we need to check to see where it is and then fix that. So we'll say, if is the ball y less than or equal to 0, question mark. If it is, what we're going to do is we're going to say that ball dot y is equal to 0. If it's not that, it means if this statement is true and the ball's y is not less than or equal to 0, it must mean that the other part of the statement was true, which means that the ball's y is greater than or equal to 300 minus the ball's height. So I don't need to do another check I don't need to add is ball's y greater than or equal to 300 because it's already automatically going to be the only other option if it's not at 0. So I'm just going to, rather than asking another question, I'm just going to set the condition what it's going to be, or set the value what it's going to be if the first thing isn't true, which is ball.y equals the height of our screen minus the ball's height. Or in other words, 290. In our case. Okay, so that's the first thing. The next thing I'm going to do is I'm going to take the, because okay, so let's say we're coming from the right to the left. The only thing in this case, all I want to do is I just want to change the y axis. Later on, we're going to adjust the y speed, but let's say if I want to change its x velocity as well as soon as it hits, this is in here is where we would do it. Later on in another place is where we're going to change its y velocity. So when the ball hits along the x-axis, we change its y speed, but if it hits along the y-axis, we change its x speed. I mean, you could do the both y and x, but whatever. We don't need to do that. We're only going to change, for this example, if the ball comes in, all we're going to do is we're going to reverse the y. So if the y was coming in at 3, once again, if the ball was coming in at 3, it's going to end up leaving at -3. So we're going to say that the ball dot y speed equals times equals -1. So if it was 3, we're going to multiply that by -1 and the new result will be -3. If it was -3, and then we're going to multiply it by -1, so it'll be +3. So we're just going to flip it. If it was negative, now it's going to be positive. If it was positive, now it's negative. And then what we're going to do, so here, if the ball comes in, the first thing it's going to do is going to check to see if it's gone below our, so let's say if this is the bottom of our screen. We're going to check to see if it's below the bottom of the screen. If it is, put it back up at the top, put it right at the edge of the screen, and then change the ball's y velocity to the opposite that it came in at, and then change the ball's X position. We'll start with the Y because that's the thing we're just finished. We'll take the ball's Y position and we'll add the new ball's Y speed. And then we'll do the same with the X. But the X we don't have any adjustments for the X, so it's just going to be whatever the X speed is currently. Ball.x plus equals ball.speed. No, ball.x speed. Yes. Okay. I think that covers everything. So it's covering right now. It's looking to see if we're hitting the top or the bottom of the screen. And then it's just, if it's coming in like this, it's going to bounce. If it's coming in like this, it's going to bounce. Okay, that's it. Now what we're going to do is we're going to do the thing that's going to be different, that gives us our different patterns, our different vectors or whatever. So if it hits along the x-axis, what are we going to do? We're going to say else if here, this statement here, I think we can actually put this in an else. Here we'll use an else. So what are we going to be looking here? We're going to be looking to see if the ball's x position is less than or equal to 0. Nope, 10, because we want our margin. We want our margin. So if the ball's position is less than or equal to 10, or if the ball's x position is greater than or equal to the left side of our screen, the right side of our screen, or the width of it minus our margin minus the ball's width. So I'll ignore the fact that there's a margin and I'll just incorporate that into it. So I'll assume that the width is actually 590 instead of 600 minus 10 for our margin. So I'll just do 590 minus the ball's dot width. Like I said, I'm going to include the balls. I could just type this all out as 580, but I want you to get used to using the width for calculating the right side and the bottom of your object, because we can get the left and top. That's part of that's what's included in our Y and X. But this corner here, we need to do that extra little calculations for. So I want you to get used to having that as part of the right side or bottom. So if we're hitting there, what we'll do is we will test to see which side we're on again. So that way we'll do our compensation to make sure that if we've gone, so if this is our left hand side, if our ball ends up going past the edge of it, what we'll do is we'll reset it so that way the ball is actually on the edge. So if the ball goes past the edge, immediately we'll set it so that it's on the edge. So we'll do a ternary, and we'll say ball dot x, is it less than or equal to 10? Question mark. If it is, ball dot x equals 0. Other words, we must be on the right hand side of the screen. So ball dot x equals the width. Nope. Once again I'm gonna adjust for the margin. 590 minus ball width. Okay, so I hope you're clear with what we just did there. We're testing to see if we're on either side, and now in here we're seeing which side we were on and making sure that our values are right on the exact edge rather than over the edge, because we don't want this. Okay, the next thing we'll do is You know what? There's another way I can do this. This would have been simpler if this was all it was doing, but we're also going to, if we hit along the x-axis, we're also going to be leaving a mark where it hits. So this isn't going to do for us. So instead, we're going to get rid of this and then pretend we didn't have it. And instead, we're going to do if ball dot x is less than or equal to 0, we are going to say that ball dot x, no, 10, it's 10, it is 10, it's 10. We're going to say that ball is equal to 10, so if it's 9, 8, 7, 6, 5, 4, no, we don't want that, we just want it to be 10. And then what we're going to do is we're going to add a progress bar that's a thin little dash. This is just for the testing purposes. This is just the demonstration purposes that we're adding this progress. And we're going to set it to be, we'll set it to x 0 because we're going to have, so this is our left side. This is our left side minus the margin. We've left this margin so that way we can put little dashes in it. Right? So our ball never goes over our dashes. Our balls might come to here, and wherever it hits, it puts a dash. So we're going to put the dash starting at 0, going 10 pixels over. 0, going 10 pixels over. So it's going to start at 0. For its Y position is going to be whatever our ball's current Y position is. So this spot right here, that's where our dash is going to be lined up with. So it'll be ball dot Y. For its width, we'll do a width of 10 pixels and a height of 1 pixel. So it's just a simple little dash. Let me get rid of that stuff. We don't need any variable associated with it, but we do need a color for it. So for color, what we'll do is we'll just do background red. And we'll set its value to 0. Okay, so that's if we're on the right hand side. If we're on the left hand side, we'll check now. So else if ball dot x is greater than or equal to 590 minus the ball's width. If you don't understand, think about it for a second. What we're going to do is we're going to adjust the ball's x position to make sure that it is at exactly that 580. Or in other words, ball x equals 590 minus ball width. And then we're going to add another progress bar on that side of the screen, showing where the ball hit. So our x position is going to be 590. So our margin for the right hand side is this point right here is x equals 590. This is the edge of our GUI at 600. So our starting position of the line that we're going to create starts at 590. Its Y position is going to be whatever the ball's current Y position is, because we're marking where the ball hit. The width and the height will make the same as it was before. Width at 10 pixels, the height at 1 pixel. and the background we'll make red, and we'll set it to a value of 0. Okay, so that's what, now that that's just showing where it hit. Now we need to actually say what happens when it hits that. So what's going to, unlike before, where all we did was we took the, so with the top and the bottom, we took, if it comes in at this direction, we make it leave at that direction. For the left and right, we're going to do something a little bit different. So let's say if it comes in at this angle right here, what we're going to do is we're going to take the x value and we're just going to reverse it like we did with the y's value up here. So we're just going to multiply it by -1. But with the y speed, what we're going to do is we're going to give it a random value in a random decimal point within its speed. So if it was speed was 3 to begin with, now we're going to add a random decimal point to that. So it could be 3. It could leave it at a value of 3, 3.1, 3.2, 3.3, all the way up to 3.9. So we'll pick a random value, and like I said, when you're programming, if you're programming a paddle or whatever, depending on where the ball strikes the paddle, you could have hard-coded things that say exactly what it's going to do rather than using a random number. We're just going to be using a random number just to sort of play around with that idea. So what we're going to do is we are going to say that the ball's y speed, nope, before we do that, we need to come up with the random number. So let's do random. The number is, we're going to call the variable dot, and we're going to set it to between 0 and 9. Now I don't use random numbers that often, so I don't remember if I can actually use a decimal point or not. So rather than playing around with it and it's not worked, what I'm going to do is I'm just going to use this, and then I'll divide it by 10 in a second. Okay, so we have a random number now that's between 0 and 0.9, or will eventually be between 0 and 0.9. And we will say that the ball's new y speed is equal to the, first thing we'll do is we'll reround our ball speed down to the lowest, to the nearest number. So if it was at 3.1 or 3.2 or 3.8, 3.9, we'll make sure that it gets reset back to just 3, and then we'll add our dots value. So we'll say ball dot y speed floor divide by 1. So get rid of it. If there's any decimal points, get rid of it. Round it down to the nearest number. And then what we're going to do is we're going to add whatever we got from dot, our dot random number, divide it by 10. So if dot is 9, it'll now be 0.9. If it was 5, 0.5. So it's 3.5, whatever. Or 3.6, 3.7, 3.8. Right? Okay, now that we've adjusted what the speed is going to be, now we need to apply that speed to our ball. So up here, when we hit the bottom of the screen, we reversed the y-axis. This time we're not reversing the y-axis, we're just changing its speed through a process here. But with the x-axis, because we're hitting, let's say if this is the left side, because we're hitting this side, we are going to reverse its direction. So if it came in this way, it's going to leave that way. So we'll start with that. Ball dot x speed times equals -1. So if it was a positive, now it's negative, and so on. Then what we'll do is we'll say ball dot x position plus equals ball dot x speed. And then we'll do the same with the ball's y position. We're just going to update it with its new position relative to its speed, since we changed its speed up there. So it's going to be ball dot y plus equals ball dot y speed. So in our case, so let's say it came in, the y value is coming in at 3. All right. When we leave, we might be leaving at 3.3 in the y-axis. And then when it hits the other side, it'll be leaving at 3.1, 3.6, 3 point whatever. Okay, I think that's everything we need there. And we already have it drawing it, so we've tested to see if the ball is still in the middle of the screen. If it is, just take the speed, the setting for our speed, and apply that to our positions. If we've hit the top or bottom, reverse the y value. So if it came in going down, now it leaves going up. However, if it hits either of the right side or the left side, we're going to change what the y speed is, so that way we get new trajectories. And like I said, you can also do the same thing that we're doing for the y with the x. So when it hits the top, or, for example, when it hits the top or bottom of the screen, you could have it come in at x equals 3 and leave at x equals 3.9. Okay, that's that. So let's go ahead and run this. And now when it hits over here, it should leave a mark. So we get a little mark. When it hits over here, we should get a mark, mark, and a mark. And if we let this run for a while, eventually this whole side here would be completely red with no black spaces in between it, except for the bottom 10 pixels because that's the height, or 9 pixels because that's the height of the ball. Likewise with this side here, right? So to prove that, let's go ahead, and what we'll do is we'll take all of this code here. Well, let me condense this a bit. I'm just going to condense this a little bit so that way it fits a little bit neater so you can see it. I don't like this margin, this indentation, but I'll do it just so that way we can so I can show this a little bit easier. So what we'll do is we'll take all this stuff where it's checking the ball's position and then updating it with new values. We'll take all of that stuff and we'll put it inside of a loop. So every single time our game cycle happens, it's going to loop over calculating where the ball is several times. And what we'll do to start with, we'll start it with like 10. So we'll loop over all of this stuff 10 times. And then only once every 10 times it moves, it'll draw it. So let's go ahead and run this again, and we should start seeing the ball moving a lot faster across the screen. Okay, so we can start to see it getting those different points a lot faster. And if we want to really speed it up, we'll change this to, let's say, 1,000. So it's going to move the ball 1,000 times before it actually draws where the ball is. So it should be adding these progress bars really, really quickly. So we get to see exactly where exactly it hits. So we can see every time it hits the side, it marks where it hit. And we can see that it's hitting every single point. Eventually it'll be completely solid red, except for the bottom couple of pixels because of the height of the ball. And because it's doing this with the left and right side, we can infer that it would also be doing it for the top and bottom as well. That's why we're not bothering to display it, because we can infer that if it's doing this here, obviously it must be getting new X positions that it's hitting along the X-axis as well. right? And after a little while, eventually, we got one more on this side. Oh, there, it's completely hit every single point on this side. It's got 3 more to hit on this side. 2 more. 1 more. And whatever, eventually it'll hit that one spot. There it's hit it. So now it's hit every single possible point on this left and right. Okay, and that's it for this tutorial. Like I said, you should take this and apply it to interpret how this works and apply it as you need for whatever you're working on or whatever you want to do with it. So I've created a box. Your job is to understand what I said and to then think outside of that box. Alright, peace. We'll see you guys on the next one. Maybe on the next one, if you guys want, let me know in the comments. If you want, what we can do is maybe create an AI for a ping pong game. So what we'll do is we'll create an AI that returns the ball or whatever. Or we can go on to something else. I don't know. Anyways, peace.